Okay, in this lesson, we're going to be discussing the determinant of a matrix. Every square matrix, and I want to point out that it only works for square matrices, 2 by 2s, 3 by 3s, 4 by 4s. Every square matrix has a real number, and the determinant will be just a number, called its determinant. The determinant of a matrix is denoted as the determinant of matrix A. Sometimes we just put DET for determinant and put it in parentheses, or sometimes we put like absolute value bars around it. Now, what a determinant actually is, we haven't talked about inverses yet, but when we get to inverses, the determinant tells you if a matrix has an inverse or not. If the determinant is 0, a matrix does not have an inverse. If the determinant is not 0, the matrix does have an inverse. Now, the actual process for finding a determinant. The determinant of a 2 by 2 matrix is super easy. The determinant of a 2 by 2 matrix is called a second order determinant because of it's a 2 by 2. To find the determinant of a 2 by 2, use this rule. I always say down minus up. And what I mean by that, in order to find the determinant of this matrix, all you've got to do is multiply these two numbers. You're going to do A times D, and then you're going to multiply these two numbers, the up numbers, C times B, and then you subtract it. A times D minus C times B. So let's go ahead and find some determinants. Again, the determinant of the matrix is equal to down, -4 times -10 is 40, minus up, 5 times 3 is 15. The determinant is 25. The determinant here, down, is 12, minus up is a -33, minus minus is a plus, that gives you 45 for a determinant. Number 3, down is -45, minus up is +35. That will give you a -80 is the determinant. And number 4, down is -16, minus up is 24. That gives you a determinant of -40. So because all of those had determinants not equal to 0, every one of those would have inverses when we get to inverses. The determinant of a 3 by 3. Now, this is a shortcut. You can use what's called expansion by minors, but this is a shortcut for finding a third order determinant, or the determinant of a 3 by 3. To find this determinant, we use these steps. We're going to rewrite the first two columns to the right of the matrix. Step number 2, find the sum of the products of the downward diagonals. We're still doing down. Minus, find the sum of the products of the upward diagonals. Subtract the upwards from the downwards. We're still going to do down minus up. So here we go. Shortcut. Take the first two columns and recopy them. 3, -5, 1, -7, 4, and 5. And we're going to take our downward diagonals here. We're going to multiply these numbers. We're going to multiply these numbers. Whoops. Try again. And then we're going to multiply these three numbers. So when you recopy those, you should have 3 sets of numbers that you're going to multiply. 3 times -4 times -1 gives you a -12, plus -7 times -5 times a +1 gives you a 35, plus 2 times -5 times a 10 gives you -50. Those are your downs. Now let's do our ups. Start down here in the bottom right-hand corner or bottom left-hand corner and multiply these 3. Then we're going to multiply these 3, and then we're going to multiply these 3. After a while, you might get pretty good with this to where you can see what numbers would be to the right, and you don't have to recopy those columns. But for now, we're going to. So your ups, 1 times 4 times 2 is 8, plus 5 times -5 times 3 gives me a -75, plus -1 times -5 times -7 gives you a -35. So therefore, let me go ahead and add them together now. My downs were -12, 35, and -50, which is -27. My ups, 8, -75, -35 is -102. So now we simply do down minus up still. That's going to be minus minus is a plus. -27 plus 102 gives me 75 is my determinant. Okay, let's try another one. Number 6. My downs, I'm first going to recopy my first two columns. 6, negative 1, and negative 3, negative 3, 4, and negative 6. My downs are these three numbers, and these three numbers. So when I multiply my downs, I have negative 96 plus 18, which is negative 3 times 2 times negative 3, plus 36. Add those together and you get a negative 42. Now let's do our ups. Multiply these three, then these three, then these three. So negative 3 times 4 times 6 is going to be a negative 72, plus negative 6 times 2 times 6 is going to be a negative 72 again, plus negative 4 times negative 1 is 4 times negative 3 is a negative 12, which gives you a total of negative 156. So to find the determinant, we now simply do the down minus the up. Minus minus makes a plus, and that gives you a final answer of 114. Number 7, let's do it again. Recopy your first two columns, negative 3, 2, negative 3, 4, 2, and 8. Your downs are here, here, and here. Negative 3 times 2 times negative 4 gives me 24, plus 20 times negative 3 is a negative 60, plus negative 14. Let's see, I'm going to do negative 7 times 8 is negative 56 times 2 is negative 112. So my downs are equal to negative 148. Now let's do the ups. So start with the bottom left-hand corner, multiply those three, and those three. So my first ones are going to be 42 plus 40 times negative 3 is a negative 120, plus negative 4 times 2 is negative 8 times 4 is a negative 32, giving you a sum of negative 110. So therefore now I'm simply doing down minus up. Minus minus makes a plus. Negative 148 plus 110 is a negative 38 for a determinant. Okay, let's do one more. Recopy again your first two columns, negative 8, 3, and negative 6, negative 8, 2, and negative 2. Multiply your three downs. 8 times 2 times 0 is 0, plus negative 8 times negative 6 times negative 6 is negative 288, plus 3 times 5 times 3 times negative 2 will be a negative 30. Giving you a total of negative 318 for my downs. Now let's do my ups. Negative 6 times 2 times 5, that's going to be negative 60. Negative 2 times negative 6, and instead of doing plus every time, you can just see if it's a positive or negative. Negative 2 times negative 6 is 12, times negative 8 will be a negative 96, so plus negative 96. And then 0 times anything will be 0. So you get negative 156 for your ups. So down minus ups, minus minus is plus, gives you a total of negative 162. Okay, next up, let's actually look at some applications. One of those applications is finding the area of a triangle. Given a triangle with these vertices, so if you're given some points that are the vertices of the triangle, the area can be found by using this formula. Area is 1/2 times the determinant of your matrix X here. So triangle PQR has these vertices. So let's create that matrix. We have, again, negative 5, negative 2, 3, 9, and 7, negative 4 are our three coordinates. We can simply put ones in that last column. Let's find the determinant. So we'll call it matrix A. So therefore, the determinant of A, again, we can do it with absolute value bars. What we're going to have to do is recopy those first two columns again. So let me space this over a little bit. Negative 5, 3, 7, negative 2, 9, and negative 4. So the determinant of A is equal to the downs. which is going to be negative 5 times 9 times 1, which is a negative 45. Negative 2 times 1 times 7, which is negative 14. And 1 times 3 times negative 4, which is negative 12. So my downs are equal to negative 71. My ups, 7 times 9 times 1 is 63. Negative 4 times 1 times negative 5 is a positive 20. 1 times 3 times negative 2 is a negative 6. So my ups are equal to 77. So when I do down minus up, I get negative 71 minus 77, which is a negative 148. And I didn't point out that we are going to take the absolute value of the determinant. So therefore, my area of this triangle is now 1/2 times the absolute value of the determinant, which is 148. So I have an area of 74, and that's it. Okay, let's try one more. Wellspring is 14 miles north and 3 miles west of Chester. Hilford is 8 miles east and 5 miles north of Chester. Find the area of the land formed between these three towns. So first off, we're going to let Chester be at the point 0, 0. Wellspring is 14 miles north and 3 miles east. So we're going to go up 14 and over 3. So that's going to be located at the point 3, 14. And again, that is Wellspring. And then Hilford is 8 miles east and 5 miles north. So we're going to go 8 east and 5 north. Somewhere over here, that's going to be 8 east, 5 north. And again, that is Hilford. So what is the area formed by the triangle that connects the three towns? So Chester's at 0, 0, and then you see the other 2 points. So first off, let's create our matrix. The 3 points are going to be 0, 0, 3, 14, and 8, 5. And again, we just put ones in our last column. Let's find the determinant of that. Let me just draw an arrow. The determinant, we've got to recopy. I forgot. We've got to recopy our first 2 columns, 0, 3, 8, 0, 14, and 5. Now let's find our downs. 0 times anything times 1 is 0. 0 times anything times 8 is 0. And then 1 times 3 times 5 is 15. So that was pretty easy. My downs are equal to 15. My ups are going to be equally as easy because of the zeros. You have 8 times 14 is 112. But then you have 0 here and 0 here. So my ups are equal to 112. So down minus up is going to be the determinant. Let me go ahead and just put an arrow. 15 minus 112 gives you a negative 97. So therefore the area is equal to 1/2 of the absolute value of the determinant. So we make it positive. So the area of this triangle is going to be simply 48.5. Now the other way that you could have done this, and it's going to take a little bit longer, is you could have found the distance here, you could find the distance here, and the distance here. And the other way of working this is by using Heron's formula, to where if you have the 3 side lengths, you can find the semi-parameter by taking half the parameter and then plugging that in for S, and then the 3 side lengths for A, B, and C, and you would have got the exact same answer.